Category 1 or Cat 1 is the oldest communication cable and was designed only for voice telephone signals. It usually contains just one pair of copper wires and supports very low frequencies. This made it perfectly adequate for traditional phone conversations, but when the digital age arrived and computers began demanding faster data transmission, Cat 1 simply couldn't deliver. The cable struggles with anything beyond basic voice communication and was never included in modern networking specifications, which officially begin at Category 3. If you happen to discover Cat 1 cabling in an aging building today, understand that it's essentially a relic. It won't support your internet needs, and attempting to use it for network connectivity would be an exercise in frustration. Anyone serious about network performance should look toward Cat 5e or Cat 6 as minimum starting points. Category 2 represented a step forward from basic phone lines capable of handling both voice communications and the earliest forms of data transmission. This cable typically featured 4 twisted pairs of copper conductors, a design choice that helped minimize electromagnetic interference during that era. Cat 2 found its primary application in legacy networking architectures such as ArcNet and the 4 megabit token ring systems. However, its maximum throughput caps at approximately 4 megabits operating at 4 megahertz, which falls catastrophically short of contemporary internet requirements. The cable never received formal approval from organizations like the TIA, EIA, meaning it wasn't engineered for genuine Ethernet deployment. In today's landscape, Cat 2 has no practical value for internet connectivity. Current networking infrastructure demands Cat 5e as an absolute baseline for dependable speed and consistent performance. While Cat 2 marked progress in its time, it's now nothing more than an obsolete footnote in networking history. Category 3 emerged during the early 1990s, serving both telephone infrastructure and the first generation of computer networks. This cable delivers speeds reaching 10 megabits per second at a 16 megahertz frequency, and it holds the distinction of being the first cable officially standardized for fundamental Ethernet applications. Open up a Cat 3 cable and you'll discover twisted pairs of copper conductors inside. This twisting isn't merely decorative. It serves a critical engineering purpose by substantially reducing electrical interference and signal degradation. Without this twist configuration, signals experience leakage and cross-contamination, resulting in unreliable connections and degraded performance. The twisting innovation, though seemingly simple, represented a significant advancement in cable design. Cat 3 maintains signal integrity over distances up to 100 meters, establishing a distance specification that subsequent Ethernet standards continue to honor. However, measured against modern bandwidth requirements, it's woefully inadequate. You might still encounter it in older structures where it supports legacy voice systems or basic security equipment, but for actual internet connectivity, it's far too limited. Cat 5e or superior cabling should replace it in any serious network installation. Category 4 cables utilize twisted pair technology in early networking deployments. These cables supported transmission speeds up to 16 megabits at 20 megahertz frequencies, which satisfied the requirements of older systems including token ring networks and certain primitive Ethernet configurations. Similar to its predecessors, Cat 4 employed 4 twisted copper pairs to combat interference. Unfortunately, Cat 4's relevance evaporated rapidly as faster networking standards materialized. Modern cabling specifications no longer acknowledge it, and it cannot satisfy today's performance expectations where gigabit speeds represent the baseline standard. Put simply, Cat 4 had utility several decades ago, but it possesses zero relevance in contemporary networking environments. Category 5 cables once dominated home and business networks as a go-to twisted pair Ethernet solution. These cables accommodate network speeds up to 100 megabits at 100 megahertz, which represented impressive performance during their heyday. Cat 5 contains 4 twisted copper pairs to suppress interference and typically terminates with the ubiquitous RJ45 connector. Network administrators deployed Cat 5 to interconnect computers, routers, gaming systems, and IP surveillance cameras. When properly rated, these cables can even deliver power over Ethernet capabilities. The recommended maximum deployment length remains 100 meters to prevent signal degradation. However, Cat5 has been superseded by Cat5e and is now regarded as inadequate for fresh installations. Contemporary networks require faster throughput and enhanced reliability, making Cat5 unsuitable for anyone establishing or modernizing a network infrastructure. Category 5E, where the E denotes enhanced, ranks among today's most prevalent twisted pair Ethernet cables and was engineered to accommodate speeds reaching 1 gigabit per second. It functions at 100 MHz, identical to standard Cat5, but implements more rigorous specifications to minimize crosstalk, delivering superior signal quality and network stability. Cat5e typically employs the standard RJ45 connector and maintains performance across cable runs up to 100 meters. It offers backward compatibility with older Cat5 and Cat3 hardware, simplifying integration into existing installations. While Cat5e remains excellent for most residential and small business networks, many users now opt for Cat6 to achieve even greater performance headroom. Cat6 represents a faster, more sophisticated evolution of Cat5e, delivering speeds up to 10 gigabits over shorter distances and 1 gigabit across the full 100-meter span. It operates at an elevated 250 MHz bandwidth, enabling higher data throughput with reduced interference. Cat6 cables utilize 4 tightly twisted copper pairs and frequently incorporate a plastic separator spline to diminish crosstalk and signal contamination, providing enhanced stability. They employ the identical RJ45 connector and maintain backward compatibility with earlier standards, facilitating straightforward upgrades. Due to its improved performance characteristics and reliability, Cat6 has become the recommended selection for modern residential and commercial networks. Cat6a, or Category 6 Augmented, constitutes an enhanced Ethernet cable standard supporting 10 gigabit speeds across the complete 100-meter distance. It provides double the bandwidth of Cat6 at 500 MHz and furnishes substantially improved protection against interference and alien crosstalk. Cat6a cables exhibit greater thickness and reduced flexibility due to tighter twist configurations and optional shielding layers, which complicates installation in confined spaces. They utilize identical RJ45 connectors and maintain full backward compatibility with Cat6 and Cat5e systems. Cat6a proves ideal for high-speed, reliable networks in residential settings, offices, and data-intensive environments. Category 7 represents a high-performance Ethernet cable standard defined by ISO IEC Class F for exceptionally demanding network environments such as data centers. It accommodates speeds reaching 10 gigabits over 100 meters and can achieve elevated rates of 40 gigabits at 50 meters, with 100 gigabits possible over very short runs under controlled laboratory conditions. With bandwidth reaching 600 MHz and comprehensive SFTP shielding surrounding each pair, it delivers outstanding protection against interference and alien crosstalk. Unlike Cat5e or Cat6, Cat7 requires specialized connectors such as GG45 or Terra rather than the common RJ45 interface. While it can function with older equipment, achieving full performance demands Cat7 rated connectors and compatible hardware. Today, Cat6a often receives preference due to superior compatibility and reduced installation complexity. Cat7a represents an upgraded networking cable standard defined by ISO IEC Class FA, designed for speeds exceeding standard 10 gigabit applications. Its most significant advancement over Cat7 involves bandwidth, leaping from 600 MHz to a full 1000 MHz or 1 GHz. It can transmit 10 gigabits over 100 meters and, in controlled laboratory testing, has demonstrated potential for 40 gigabits at 50 meters and even 100 gigabits at extremely short distances. To manage its elevated frequencies, Cat7a implements heavy SFTP shielding on each twisted pair plus an overall shield, making the cables considerably thicker and more challenging to install. It also depends on specialized connectors like GG45 or Terra instead of standard RJ45, which restricts compatibility. Because of these factors and the absence of official recognition by the USTIA, Cat7a never achieved widespread adoption in residential or commercial settings. For most future-proof installations, Cat6a or Cat8 represent more practical and widely supported alternatives. Cat8 stands as the newest copper Ethernet cable standard officially recognized by the TIA and is constructed for extremely high-performance environments like data centers. It supports blazing transmission speeds of 25 and 40 gigabits operating at frequencies reaching 2000 megahertz, far surpassing older cable categories. To sustain these speeds, Cat8 is restricted to a maximum distance of approximately 50 meters. Anything beyond those rates typically requires fiber optic technology. It also incorporates heavy shielding to eliminate interference and preserve signal integrity at its extreme frequencies. The positive aspect is that Cat8 still utilizes standard RJ45 connectors, ensuring backward compatibility with previous Ethernet hardware. While you could theoretically deploy Cat8 in a residential setting, most consumer devices and internet service plans cannot leverage its exceptional speeds. For realistic future-proofing purposes, Cat6a typically represents the smarter and more economical selection. And there you have it. We've journeyed from humble telephone wiring all the way to cutting-edge data center connections. Now you understand exactly what technology sits behind your network port, ready to transmit your data at lightning speed. If you found this information valuable, subscribe to my channel for more tech explanations. See you in the next video.